Okay, let's get started coding our linked list. For most of the coding that we will be doing in this course, we will be using a free online text editor called REPL.it. So head over to REPL.it, hit this Start Coding Now button, and choose JavaScript as the language. So we just went over constructor functions, and we know that we want to use them to create our linked list and to create the nodes that will be in our linked list. Let's do that now. We will write a function called linked list, and this will be our linked list constructor function. And for our node constructor function, we will write a function called node, and this will be our node constructor function. Okay, great. So we know that our linked list and our nodes are both going to have some properties on them. Well, which properties are they going to have? We can check that out over here on our diagram from before. We can see that each node will have three properties on it. It will have a value property, which will be some data. It will have a next property, which will basically encompass or point to the next node in the list. And it will have a previous property that will point to the previous node in the list. Now, we know that our linked list is only going to have two properties on it, right? It's only going to have a head property and a tail property, and that's it. So let's go fill those in now. So in this linked list, instead of passing in head and tail as parameters, we are going to initially set the head and tail properties equal to null. And the reason that we are going to do this is because when we initially create a linked list with this constructor function, there is not going to be any nodes in it yet, because we haven't added any to it yet. So the head and tail pointers have nothing to point to, so we will initially point them at null. Now, for the node constructor function, like we just saw, each node has a value property, a next property, and a previous property. Let's put those in now. These we will pass in as parameters. We will say value, next, and previous. And we will assign those parameters by saying this dot value equals the value parameter that we pass in. This dot next equals the next parameter that we pass in. And this dot previous equals the previous or prev parameter that we pass in. Okay, great. So those are our constructor functions, and let's just run through an example with each real quick, just to make sure that they are functioning correctly. So we will say variable LL is a new instance of our linked list constructor function, and it doesn't take any parameters. So if we console log out this LL, we will see what we just created. Great. So we have this object that we just created, which is an instance of the linked list constructor function, and it has a head property that is set to null, and it has a tail property that is set to null, which we initially set in our constructor function right up here. And we could create a lot of different linked lists with our constructor function if we wanted to. We could say variable user list equals a new linked list and store a bunch of users in it. Or we could say variable to-do list equals a new linked list and store a bunch of our chores in it, and so on. Each of these instances that we created here is a new linked list. Okay, great. So that works properly. Now, you might be thinking, how can this linked list that we just made, this LL right here, that we just logged out, how could this possibly be our linked list? All we did was make a simple object with two properties on it. Well, if you remember back when we explained our diagram here, we said that all a linked list needs to have in order to function correctly are two pointers. The head pointer, which points to the first node in the list, and the tail pointer, which points to the last node in the list. So if we can reach the head or tail node in the list, we can get to all of the other nodes in the list because they are all connected to one another by their next and previous properties, or next and previous pointers. Okay, let's make sure that our node constructor function works properly. We will create a node instance by saying variable node1 equals a new node. We will say that this node is going to have a value of, let's say, 100. Its next property will be pointing to node2, which we will pass in as a string for now instead of as an actual node object, since we don't currently have a node2 object. And its previous property will be set equal to or pointing at null. Since this is the first node, there's going to be no previous nodes before this one. Let's console.log out this node1 that we just created to see what we have. Great, so this object we just created is an instance of the node constructor function. It has a value of 100, a next property of node2, and a previous property of null, which we just assigned to it when we passed in our parameters. Great, so it looks like both our constructor functions are working perfectly. Also, just as a little side note, don't worry about this undefined over here. That is a side effect of the console.log function in this environment, and it's not going to bother us. Okay, great. I'll see you in the next video.